Hi everyone, welcome to this video. We are now going to look at question number 2 of the FAMS sample questions. Okay, you can find these questions on the SOA website. This is question number 2. Let's read the question. You are given losses follow a single parameter Pareto distribution with density function that's given to us, alpha over x to the power of alpha plus 1, x bigger than 1, and we are told a random sample of size 5 produced 3 losses. The values of the losses are 3, 6, and 14, and 2 losses exceeding 25. And you're asked to calculate the maximum likelihood estimate of alpha. Okay, well, let's look at the question first before we start with the process. We have a single parameter Pareto, and you'll find this in your FAMS tables. Look it up, okay? And the second thing is we have a random sample of 5. They gave us 3 of those, and they tell us that 2 losses exceed 25. So just looking at this itself, we know that we'll have to use your survival function, yeah? So we need that. Calculate the maximum likelihood estimate of alpha. That's the question. Okay, let's start, right? First, we need to go ahead and look up the tables. Okay, refer to the tables. I'm not sure what page is on, right? From the tables, you will see the density function given to you for your single parameter Pareto, and you'll see that from what's given here, that the value of theta is 1. Okay, you will know what I'm talking about when you look up your tables, and then from your tables you can get your CDF. Okay. Now, if you don't want to do that, if it doesn't strike you, right? Looking up your tables doesn't strike you, then what you can do is you can go ahead and find your CDF by using an integral, right? Going from 1 to x alpha over t to the power of alpha plus 1 dt. Okay. You can go ahead and find your CDF, your cumulative distribution function, using this integral. Okay, we are going from 1 to x alpha over t to the power of alpha plus 1 dt. Clean it up and you'll get this. Okay, and like I said, we are talking about losses exceeding 25, so we need the survival function. That's easy. Just take the complement of your CDF, you'll get your survival function 1 over x raised to alpha, or just 1 over x to the power of alpha. Okay, 1 over x to the power of alpha. Doesn't matter, yeah? Either way. So next thing, as you can imagine, we have to go for your likelihood function. So the likelihood function, let's erase this, yeah? Okay, your likelihood function, I've done it here for you. We have got L of alpha. The first value here is 3. So you can just plug this in here, right? Alpha over 3 raised to the power of alpha plus 1. Done. Next value is 6. So I have alpha over 6 to the power of alpha plus 1. Done. Then next value is 14. So I'll have alpha over 14 to the power of alpha plus 1. And then I've got 2 losses exceeding 25. So I'll have 1 over 25 plus 1 and second one. Okay. So I'll get 1 over 25. Alpha plus alpha is 2 alpha. That's what you see here. Okay. When you're done with that, we need to clean this up a little bit. Okay. This is your likelihood. So we need to go ahead and take your log likelihood. So let me just move the screen up, right? Move the screen up. Give me a second. Yep, pretty good. Okay, now I can clear this. Give me a second. Okay, good. So now we are here, right, folks? We are here. Then when you clean up the algebra, you'll get this. Do that slowly, yeah? There's an alpha cube in the numerator. There's a 252 raised to the power of alpha plus 1. I've just used indices, yeah, basic indices. You can see it happening here. There's alpha plus 1 here and so on. So, and then I've got a 25 raised to the power of 2 alpha. Okay. Then once you've settled that, rewriting in the form that I like. so that I can get my log likelihood, right? This is my likelihood. Let me write it here. This is my likelihood function. This is my log likelihood function, yeah? This one. So my log likelihood function, I just call this log of L of alpha, or you can just call it the small case L, right? And when you do that, take logs and you'll get this, right? Pretty easy. Then what do? Take the derivative, right? Take the derivative. And when you do that, you'll get 3 over alpha minus log of 252 minus 2 log 25. Okay, you can see it from here. 3 over alpha, because there's alpha here and log 252. We are taking the derivatives with respect to alpha, so it's just minus log of 252. And then we've got minus 2 alpha log 25. So when you take the derivative, it'll just be minus 2 log 25. Okay, then we're going to set your derivative to 0. Set your derivative to 0. You'll get an equation here, solving for alpha. Okay, solving for alpha, we will get the final answer. Okay, just use your calculator carefully and you'll get 0.251, and you'll find that your answer is A. Okay, the answer is A. They gave us as, okay, A is 0.25. Okay, that's your answer, and we are done. Okay, so go through it carefully. Not a difficult problem, pretty straightforward, and I'll see you in the next video.